Professor Dr. N. Gunasekaran, retired senior professor, after serving about 40 years in Electronics and Communication Engineering Department, College of Engineering, Anna University, Chennai. He is presently working as Principal, Pratyusha Institute of Technology and Management, Tiruvallur, Chennai. He has 40 years of teaching experience in the field of electronics and communication engineering. He had visited countries such as USA, UK, Germany, and Sri Lanka on various academic activities. He has about 90 research papers to his credit. He has guided 6 PhD scholars and 3 MS program scholars. He has published 10 books and 10 monographs. He has attended 19 short-term courses. He submitted 33 proposals to the Development of Electronics Department. He had purchased equipments to the tune of Rs 150 lakhs for the growth of the department. He has developed many laboratories such as Microwave Lab, Fiber Optical Communication Lab, Laser Communication Lab, Satellite Communication Lab, VHF-UHF Communication Lab, and UG Basic Laboratory. He conducted more than 50 short-term courses, winter schools, summer schools, and faculty development programs. He executed a number of government-funded projects at Anna University. He received Best Project Awards twice for UG projects at state level through Directorate of Technical Education and at national level President of India Award for the project on telephone for physically handicapped persons. He is a member of many professional bodies such as Institution of Electrical and Electronics Engineering, Fellow of Institute of Electronics and Telecommunication Engineering, and Broadcast Engineers Society of India. He is also a life member of Institution Engineering, life member of Indian Society of Technical Education, and life member of Optical Society of India. His current fields of interest are electromagnetic theory, antennas, satellite communication, and fiber optical communication.
Welcome to UGC lecture series in Applied Electronics. The lecture covers semester 5, paper 10 on antenna and wave propagation. The first unit covers fundamentals of antennas, in which we are going to discuss on antenna action, short electric doublet, radiation from doublet antenna, thin linear antennas, current distribution on resonant and non-resonant types, effect of ground, image antenna, field strength at a point close to the antenna within the range of direct ray. Let us define what is an antenna. When you say antenna, the terminology coming to our mind is radio and wire communication or wireless communication. Radio implies wireless communication, wireless implies radio communication. When you say radio communication, always people get into their mind an antenna which is meant for radiating, an antenna which is meant for receiving. If you see the general block diagram of an antenna, now there is a transmitter which is having a transmitting antenna, and there is a receiver which is having a receiving antenna. In between free space, there is no physical connection involved. That is why it is called wireless communication. There are other applications where communications are made using wires. For example, telephone, telegraph. Those are the communications where wire becomes a part and parcel of the system. Whereas in wireless communication, antenna is the only means of linking a transmitting station and a receiving station, whereby the information is transmitted from one part of the world to the other part of the world, or from any one point to the another point. Thereby the concept of wireless communication get into the picture. The moment wireless communication implies the antenna is becoming part and parcel of the system. Now information is coming from transmitter. information is reaching to the receiver. In between we require a link, and that is covered by the free space. Now this space has to be linked by what is other is called electromagnetic waves. So electromagnetic wave becomes the link between transmitting antenna and receiving antenna. Now the point is how these electromagnetic waves are generated by the transmitting antenna, and how this electromagnetic is they are received by the receiving antenna, and how this signal transmission or conversion taking place. Because when we speak, what we are speaking, acoustic signal, the acoustic signal converted into electrical signal, the electrical signal then converted into electromagnetic wave. So antenna acting as a transducer, converting electrical signal into electromagnetic waves, whereas the other end, on the receiving end, the electromagnetic waves are converted back into electrical and again back into the acoustical concept. So we have to understand what is the real role of an antenna and how antenna does a job of this conversion. And I wish to show few general antenna pictures which you come across in your day to day life, that will give you a confidence that how an antenna looks and how this antenna does such a marvelous job. Because we can say antenna itself called as an electronic eye. It is an electronic eye given to a human being to see the whole world, because with a normal eye we are only seeing physical object, whereas with the electronic eye we are going to see electromagnetic wave. The electromagnetic wave represent our voice, the electromagnetic wave represent the video picture, the electromagnetic wave represent digital data. So we are very fortunate to have a natural eye gifted by God and an electronic eye which we call as a antenna. So antenna is an electronic eye helping us to get electromagnetic waves, and electromagnetic waves are carrying all type of information. Fine. Now the whole world is covered by communication only. Without communication there is nothing on earth, and the very beauty of this electromagnetic wave is the speed with which the electromagnetic wave is traveling is enormous, enormous. This is theoretically 300,000 kilometers per second. 300 kilometers per second. What we are normally telling the speed in terms of 100 kilometers per hour, 200 kilometers per hour, 300 kilometers per hour. But now we are telling a speed which is 300,000 kilometers per second, which is a super speed beyond imagination. And what is the effect of this speed? With this speed, if the electromagnetic wave moves around, it can cover the whole world about 8 times in 1 second. In 1 second, the electromagnetic waves are going around the world 8 times. And what is the circumference of the earth? It is about 40,000 kilometers. 40,000 kilometers, such a enormous distance. 40,000 kilometers, that distance it is covered by the electromagnetic wave in just less than a second. So in 1 second means already the electromagnetic gone around the world, and already it has passed on the information to the destination. That is a simple beauty of the electromagnetic wave, and that marvelous waves are generated by a very simple antenna. This is another great gift. A very simple antenna is capable of generating such a super wave. Now with this super property of covering the total globe in just a second, in just a fraction of a second, we can cover any nook and corner of the earth. Thereby the philosophy of national hookup, national communication, international communication. These terminologies are becoming very, very common in today's communication world. The whole world, the whole globe, any nook and corner of the earth can be reached by electromagnetic wave in no time, and that waves are generated by antenna. Now, coming back to the fundamental concept, what is this electromagnetic wave? This electromagnetic is a technical word, otherwise we are using a very common word, radio waves. Radio waves is a very, very common word, everybody is using. This radio wave is nothing but electromagnetic wave, and the electromagnetic wave also called electromagnetic field. Electromagnetic field, electromagnetic wave, or simply waves or radio signal, various terminologies are we are using, all are meaning the same. So, what is electromagnetic field? It is a combination of two fields, one is electric field, other is magnetic field. So, the togetherness we call as a electromagnetic field, and this electric field is due to electric charge. The magnetic field is due to flow of charge, rather current. So, the charge produces electric field, the current produces the magnetic field. So, the combination of charge and flow of charge put together give rise to electromagnetic field, and under certain situation that we will see later, under certain situation this combination of fields is capable of reaching any nook and corner of the world. Under what situation, that we will postpone for a time being. Now, the another fundamental, very, very fundamental concept one has to understand before we go into any details, that electrons are capable of radiating energy. Electrons are capable of radiating energy when they are subjected to acceleration and retardation. Whenever electrons are subjected to acceleration or retardation, or telling in a simple word, if the velocity of electrons are modified, changed, increased or decreased, then electrons are capable of radiating energy. Then what is an electron? The logical question, what is an electron? The electron we can visualize as a packet of energy. Though it is a very, very, very small packet, but it is a packet of energy, and with one electron nothing can be done. We are going to talk about millions, billions, millions of electrons flowing at any one point of time in any circuit. So, with the enormous number of electrons, the energy available to us is reasonable. With that energy we can do wonder. So, when electrons are subjected to acceleration and retardation, then energy getting radiated. Energy was inside the electron as a potential energy. Energy was inside the electron as a potential energy. When electrons are subjected to acceleration or retardation, that potential energy converted into kinetic form, and that kinetic form is now coming out as a radiation. So, the very important point in antenna, the most fundamental point in antenna one has to appreciate and understand and remember, electron when they are made to flow, electrons when they are made to accelerate and retard, then radiation will come out. Energy is coming out as a radiation. Next logical question, where is electron? Where is electron? Electrons are not available in any open market or international market. Again, God is very, very merciful to the humans being. Electrons are available in all conductors. In all conductors, electrons are available. Electrons are available whichever the material you claim as a conductor. Aluminium, copper, gold, silver, you take any good conductor, electrons are available in plenty, in plenty. So, thereby when electrons are made available in this conductor, and if you make the conductor is further purified conductor, then these conductors are providing electron as we wish. See how the nature is so kind to us to provide us a very big gift. We are talking about a super wave on one end. The electromagnetic wave is a super wave, that is one end, whereas from where they are coming, we are getting those electromagnetic wave from an electron, and these electrons are available in a very simple conductor. So what we are observing now, a simple conductor. You can see a simple conductor where the electrons are made to flow. You can see a small conductor, okay, this is small conductor, and again this diagram shows there is a plenty of electron getting accumulated on one end, and there will be a depletion of electron from the other end. So there is an accumulation of electron. When electrons are made to flow, electrons are provided from this end, from the source end. When electrons are provided from the source end, electrons are made to flow, but they cannot escape because this is a free space. So electron flow on this side, getting blocked, getting accumulated, again flow to this end, stopped, getting accumulated, again turn the direction, go to that side, turn the direction, go to this side, turn the direction, go to this side. Like that, electron is shuttling between these two ends because there is no conducting path. So what is happening? There is an accumulation of electron, that what is shown here as a small spherical shaped block. So that is indicating accumulation of electron on one end and depletion of electron on the other end. So as applied source changing its polarity, the electron flow will be making this end to this end, this end to this end. So you see there are two things happening. Please observe, there are two things happening. What are the two things? One, charge. We said two fields, electric field, magnetic field. On one side we are now getting introduced to charge. What is the second we are getting introduced? The flow of charge. Charge and flow of charge. Please remember, we said charge is a source for producing electric field, flow of charge is a source for producing magnetic field. The togetherness of these two fields will become electromagnetic field. So we are slowly getting to the origin from where the electromagnetic wave is getting initiated. So electromagnetic wave is initiated from charge. Charges are available in plenty in conductor, and in conductor when electrons are subjected to acceleration and retardation, then they emit energy. So we will have a very short break and continue the same topic. Welcome back after the small break. Now we will continue on where we left. Now let us recall few important terminologies. Antenna is one word we used. What for antenna? Antenna is a link between transmitter and receiver. Antenna linking the transmitting end and free space to the receiver. Second terminology we introduce, the signal what we are talking are called electromagnetic waves. The third terminology we used, the electromagnetic field or wave are nothing but a combination of electric field and magnetic field. Okay. The next point we said, charges produce electric field, flow of charge or current produces magnetic field, and the combination of electric and magnetic field constitute energy, and the energy nothing but the signal. The signal may be audio, the signal may be video, the signal may be data, digital data. So what we say in a normal terminology, a song, an audio, a picture, a data, that is a non-technical terminology that we call as a electromagnetic wave or energy. So somehow we should convert these signals, voice, video data into electromagnetic wave. So, we want a converter capable of converting from original voice, signal, data, video into electromagnetic wave, and that is done by antenna. So, if someone asks what is an antenna? Antenna is a transducer. It is a transducer. It is converting one form of energy into another form of energy. What is one form of energy? Signal. Signal can take audio, video, data. That is one form of energy. What is another form of energy? Electromagnetic waves. So, antenna is a energy converter. Obvious question is why it has to convert? Why it has to convert? It's very simple. My voice has to go throughout the world. My picture to be transmitted throughout the world. The data I am sending should go throughout the world. So, how to send throughout the world? That is done by antenna. Antenna radiates. The moment the word come across antenna, it radiates into the space. What it radiates? It radiates signal, it radiates music, it radiates picture, it radiates data. Once antenna converts the original signal into electromagnetic waves, it radiates. So, the wave itself implies the one which is getting radiated. When you say wave, it is a radiated entity. When you say wave, it has to go at a super velocity 300,000 kilometers per second. So, once antenna converts the signal into wave, it just spreads, radiates. It does not bother about the distance. The whole world is covered in a fraction of a second. The moment Voice of America is on, you get the news. The moment Doordarshan is on, you get the picture. The moment data transmitter is on, you get the data. We are getting data from satellite in no time. We are getting picture from the satellite in no time because they are all electromagnetic wave. Such a super work done by a conductor, a simple conductor. A conductor has got plenty of electrons. If these electrons are made to flow in accordance with the signal, only thing we should see with our electronic system, these electrons should flow similar to our voice. These electrons should flow similar to our video, picture. In a conductor, these electrons should flow similar to data. So, what we are doing? We are converting signal into electron flow. When you say flow, electrons are accelerated, electrons are retarded. When electrons are given energy, they are getting accelerated. When the electrons are not given energy, they are decelerated. So, thereby what happened? The signal making the electron to move fast. When the signal is not given, the electrons move to go slow. Thereby, by moving electron faster and slower, the energy getting radiated. Energy was inside the electron before radiation. Energy is coming out of the electron after radiation. So, antenna is a radiator. You see, now we are slowly developing the definition. What is an antenna? It is a radiator. What is an antenna? It is a conductor. What is an antenna? It is a transducer. Antenna radiates electromagnetic wave. Antenna is a simple conductor having plenty of electron having energy. Antenna converts electrical to electromagnetic wave. So, like that slowly we are developing the definition of antenna by virtue of its functions. And what we are seeing is a simple conductor. This simple conductor has plenty of electron, and the energy we are giving make the electron to flow faster or slower. So, this is called dipole. Please don't, here onward we are slowly adding more terms, technical terms. It is called dipole. Di means what? Two. Di means two. Pole means polarity. Now you can see here is a rod, a very simple rod where electrons are accumulated. On one end electrons are accumulated, on other end electrons are shortage. There is a shortage of electron on this side. So, that way we are introducing a polarity minus and plus. Electrons are more, electrons are in shortage. So, thereby there are two polarity. So, it is called dipole. When electrons are made to flow in this dipole, then they radiate energy. Now, logical question. What is the logical question? What is its length? Simple. I said only rod, I said only conductor. What should be its length? It's a very good question now. So, we have to see what is the length of the antenna which will radiate efficiently. Please try to follow the development now. You see, we said we want a conductor. Why we want a conductor? Because we want plenty of electron. Why you want plenty of electron? Because every electron is an energy. Every electron is an energy packet. More electron, more energy. So, we want conductor, we want more electron, and all these electron having plenty of energy. And what this energy contains? The energy contains signal, audio, video, data. Okay. Now, what should be the length of the conductor? That is our next question. That we will answer now. Now, as we just now completed, it is a simple conductor. We just established our definition. Antenna is a simple conductor. Any good conductor, any shape, any size. We are going to see number of example today. We take any conductor. For example, this is a conductor. You see, this is a rod. This is called dipole. Okay. This length can be extended. You can see this length can be extended. So, this is a dipole. Positive polarity, negative polarity. So, dipole. This is one dipole. This, if you reduce the size, this is another dipole. This is the conductor. Dipole is a special name we are giving. Otherwise, what it is fundamentally called? Conductor. This is another antenna, conductor. This is another antenna, fundamentally conductor. This is another antenna, fundamentally conductor. This is another antenna, fundamentally conductor. So, what should be the fundamental property of an antenna? Conductor. Why it should be conductor? Because I want plenty of electrons. So, to get plenty of electron, I want conductor. At the same time, this energy of the electron should come out. That is our next job. So, basically antenna is a conductor, and what is the function? It is a radiator. An antenna can be a radiator or receiver. The job is very similar, but basically it is we call it a radiator. Then what is antenna does? As we have seen the very first picture itself, antenna connecting a transmitting station, a receiving station. You can see a transmitting station and a receiving station. An antenna radiates, an antenna receives. What is in between? Free space. There is no physical link here. That is the beauty. This is a transmitting antenna, this is a receiving antenna. This is a conductor, this is also conductor. We do require a height because to cover larger area we require some height. But functionally what is this? Conductor. What is this? Conductor. Then next question, why they are different, sir? No, they are different because of they are doing different job, different type of job. Because the application point of view, from the application point of view, we need different application. For example, simple example we will take Doordarshan, All India Radio, Doordarshan. What is the function of this station? They want to throw energy everywhere. They want to throw energy everywhere. If we take satellite, satellite want to throw energy from one satellite to another place. It is only point to point communication. In satellite it is point to point communication. In Doordarshan it is 1.2 many. That's called, it's called broadcast. All India Radio, broadcast. Doordarshan, broadcast. So when you say broadcast, where we want to throw energy from one point to many, so application is different. If it is satellite communication, there is a transmitting satellite, there is a receiving satellite. So they try to throw energy from ground station to satellite, from ground station to satellite, and satellite to ground station. It is a point to point communication. The purpose is different. So like that, from applications point of view, The purpose of radiation is slightly different. There be the antenna size, shape, number of elements are differing, that we will see later. But what is the point now we should understand? What is a basic function of an antenna? It links a transmitter somewhere, receiver somewhere. Transmitter may be in Bombay, receiver may be in Chennai. Transmitter may be Calcutta, receiver may be Delhi. Transmitter may be America, receiver may be Chennai. So, the distance does not matter. The distance does not matter. Why? Why distance it does not matter? Tell me why this not, we do not bother about the distance at all, because this distance is nothing for the electromagnetic wave. The electromagnetic cover the distance in just fraction of a second. That is the speed of electromagnetic wave. So, thereby you can cover any part of the earth, wherever the transmitting antenna, wherever the receiving antenna, we can just cover any distance just in fraction of a second. So, fundamentally speaking, antenna is a link, antenna is a conductor, antenna is a radiator, antenna is a link. That is why it is called wireless communication. If we say there is no link at all, the distance is infinity. I can go to any distance, because distance does not matter for the electromagnetic wave. We will continue again the other definition. It is a transmission line expanded into antenna. I will show the diagram for that little later. Now, this can be a widened one. This is widened, but it can be a transmission line also. So, when the transmission line in a narrow form, it is called transmission line. When you are expanding this, it is called antenna. How a transmission line can be expanded into antenna and radiating, that we will explain little later. Now, it is a passive network. An active system has got energy source and it will amplify. A passive system will not have an energy source and will not carry out the job of amplification. Antenna is a passive, there is no amplifier in this, there is no amplifier in this, there is no amplifier in this, there is no amplifier in this. They are all passive system. So, it is a passive system, but still capable of doing some indirect amplification. We can't say no amplification, but it is called passive amplification. Fine. And this is also called a resonant circuit. We will explain that meaning little later. So, antenna also called a resonant circuit. What is a resonant circuit? It is equal to a tuning circuit. As an electronic student, everybody know what is a tuning circuit, what are the main components of that. It is, please understand, this is not a circuit, do not get misled. It is not a circuit, but I can draw an equivalent circuit to this as a tuning circuit. This rod is only a rod or a wire, but it can be equal to L or C. Now, it is a transducer is already. With this concept, what is the final conclusion of this? Antenna radiate, that what you are seeing, antenna radiates. It is radiating what? Electric field and magnetic field. It radiates what? Signal. It radiates what? Electromagnetic energy. It keep on radiating. And under one condition only it radiates. What is that condition? That we should do some mathematical part. So, today we have seen the very fundamental definition of antenna. So, the moment you come across the word antenna, you have to say it is a radiator. And physically what it is? Conductor. It is a conductor physically, and its main job is radiating. And what it radiates? Energy. And the energy nothing but signal. So, the purpose of antenna to establish a wireless link, thereby radiating signal, thereby linking a transparent receiver, and it does what is called global communication. Let us recall and try to see whether we can answer simple standard questions. Question number 1, what is an antenna? Very simple question, 2 mark question, simple thing we can ask. What is an antenna? For this there are number of answers are there. You have to substantiate your question with reasonable answer. The next possible thing we should know, why you prefer a conductor? Why you prefer a conductor for fabricating antenna? Second question. Now, next question, what exactly it does? What is the job of the antenna? and what it actually does to the public. What is the significance of electromagnetic wave? Very, very important. So, we will wind up with this. We will continue to and see various type of antennas. When you go around the your own place, wherever you are, you do come across a number of antennas. Are they all same, or there is something different in that? What is the difference we are supposed to identify in those antennas? So, that we will continue in our next lecture. Thank you.